Here's an example where we're estimating the height of a building. To estimate the height of the building, student finds the angle of elevation from a point on the ground down the street from the building to the top of the building at 36 degrees. Let me draw that. I think having a picture. A lot of the battle on this problem is having a good picture. So let's do our best. So we'll have this. We'll have some building way over here. So there's our building. Okay, and the student goes way far away, like say way over here, and from there to there finds an angle of 36. That's an angle. It's called an angle of elevation. Angle of elevation means up from flat. That's what that means. An angle of elevation is from flat up to looking at the top of the building. To the top of the building, 36 degrees. So there we go. So now, from a point that is 350 feet closer, the angle is 60 degrees. Okay, so now we're going to go like, say, here. And we're going to go also to the top of the building. And that angle of elevation is 60 degrees. But that's a point, 350 feet closer. So that means there's 350 feet from here to there. Do you see what they're describing? The student moved 350 feet closer, took a new angle of elevation look to the top of the building, and now the angle's grown bigger to 60 degrees, right? Oh, wait, why did I write 60? I don't know. It's 51. It's not 60. It's 51. Sorry. I'm confusing you there. 51 degrees, right? It said 51. I don't know what I was thinking. All right. From a point that is 350 feet closer, 36 was the first angle. 51 is the second. All right. Now we go. If we assume that the street is level, all the ground is flat and level, use this to estimate the height of the building. So how can we use that to find, over here we want to find h, which is the height of the building. How can we find h in this situation? Well, this is kind of a tricky little problem, isn't it? Basically, here's the game plan. If we can somehow find this side here, call it x. If we can find that side, then we can finish up by finding h with a right triangle. So this problem is difficult. It's going to be in two phases. Phase one is to find x. So step number one, find x by law of sines. Right? Because why? Because the triangle that x is a part of, this triangle, it does not have a 90-degree angle. It's not a right triangle. Right? So this is not a right triangle, so we have to use the law of sines. We must use law of sines. We cannot use SOHCAHTOA, right? You can only use SOHCAHTOA for right triangles because the h in SOHCAHTOA is hypotenuse. You must have a right angle, right? So we have to use law of sines. To use law of sines, you must have an angle and side opposites. So let's find some angles. We can find this angle, can't we? So first off, angle, the missing, that angle there, I don't know what to call that angle, angle next to 51 degrees must equal 180 minus 51, which is 129 degrees. This must be 120 degrees. Why? Because together they make 180, don't they? Right? right? Think about our graphing. That's 180 degrees. That's half a circle. They have to make 180, so subtract from 180. That missing angle there's got to be 129. Okay, great. Where does that leave us? Step 2, now we can find this top angle because the triangle has to hold 180. Top angle must be 180 minus the other two added up. So we have that top angle must equal whatever that is. Let me do it on my K. 180 minus the 36 and the 129. So that's 15 degrees. So that top angle here must be 15 degrees. Because now the triangle holds 180. Okay, why is that great? Well, now we can do law of sines in there, right? Because we have the side and the opposite angle. We can set that equal to this side and opposite angle, right? So that's what we're going to do on step 3. So use the law of sines. So we'll say 350 over the sine of 15 degrees must equal x over the sine of 36 degrees. Do you see that? Because remember, any side over the sine of the angle across from it is equal to any side over the sine of the angle across from it. That's what the law of sines says. Side over angle, where the angle and side are opposite of each other. So now I can solve that little equation for x. Diagonal, diagonal. So 350 sine of 36 degrees is x sine 15. So now divide by the sine of 15 degrees. Boom, boom. X equals, let's figure it out, 350. My calculator now, sine 36 divided by sine 15. I'm getting 794.8597. Okay, so that's x. Now that's not the end of the story. That's x. Let me write it right here now on our diagram. This is 794.8597. So I've got x. Now I can focus my attention in here. You see, because this is now a right triangle, isn't it? Do you see that? Because, why? Because height has to come straight down to the ground at 90 degrees. That's the very meaning of height, right? You don't measure your height by going diagonally down to the ground. You go straight down. So that's height. So that's a right triangle. And so now I can use SOHCAHTOA. This side here, this is the angle 51 degrees, or is it 50? Yeah, 51 degrees. This is the opposite. This is the adjacent. And this side over here is the hypotenuse in the right triangle. So I want to use opposite and hypotenuse. What's that? That's sine. Right? Do you see that? So I'll finish it up. Maybe I'd rather do it where you can see it. So let me do it right here, number 4. Step number 4. So the sine of 51 degrees is going to be the opposite, h, over the hypotenuse, the 794.8. I don't have room there, do I? And I don't really know how to do this. I want you to be able to see it. So try again, the sine of 51 degrees is the opposite, h, over the hypotenuse, 794.8597. And so now, to finish solving for that, put this over 1, go diagonal, diagonal. So that means 1 times h is 794.8597 sine of 51, if you can read that. Sorry. Sine of 51 there. Let me try that again. And so h will equal, just multiply that together on your calculator. I'm getting 617.722. I don't know how many round. Oh, whole number. Okay, so 618. So the height is 618. The height of the building must be 618 feet. Do you see that last step, number 4 there? How I did that with the right triangle. So we did a bunch of work to find this side using the law of sines. Right, we found this angle, then the top angle, then we did law of sines with these two and these two, found the x, and then we could do SOHCAHTOA, we could do sine is opposite over hypotenuse and solve for h.